Hi, to all structure engineers, steel connection engineer, how are you doing today? Today I'm going to show you how to use Civil Bay steel connection program to design the moment connection. All right, that's one of the most common type of connection is a moment connection, and the most common used one is extended end plate moment connection. All right, so I start a Google Chrome, typing the address asp.civilbay.com/connect. all right, so okay, so the interface will start with MC. All right, so as I say, the most common used one is extended end plate moment connection, and the AISC has two design guide. One is design guide 4, one is design guide 16. Okay, design guide 4 is for thick plate moment connection, which the bolt prying is not an issue. Okay, the plate is thick, end plate is very thick. The design guide 16 though is for thin plate and moment connection. All right, so where we had to consider the bolt prying actions. Okay, so that's the thickness of plate. All right, so we change to side view, and we switch to all our program are basically based on AISC design guide 4. For if the end plate you choose is thick enough to ignore bolt prying, and we switch to design guide 16 if the end plate thickness you choose is thin. Okay, the bolt prying has to be considered. So go to General tab, and we switch to side view. Okay, here we switch from front view to side view, and I have a brief introduction of this General tab input here. First, of course, is company name and project name divided by plus sign here. Before plus sign is company name, after plus sign is your project name. All right, that will show up on your calculation printout. The second one is connection ID. The third one is type of connection. We are designing MC here. We have shear, brace, and splice. All right, connection. And these MC can be right side only and left side only. You see, left side only. Okay, and can be both sides here. All right, when we switch to both sides, we have both sides of column as MC. All right, so there are two types of MC for now for this program. One is end plate to column. One is flange plate to column. Okay, I will show you what flange plate to column it is. Okay, so here you go. That's flange plate to column. We can keep more rows of bolts here on the web. So just for illustration, and we change back to end plate. Okay, extended end plate, and the other option is the beam is near the end of column. It's column top. Normally, if we switch to yes, if column top, the MC capacity will reduce. Okay, will be reduced. See this distance from top of a beam flange to end of column. See the left side highlight the dimension 4 inch. Okay. It depends on the distance. The AISC has a formula to reduce the beam web check. I will show you later. Okay, actually, see here, 4 inch. Okay, I will show you what it's about. Let's say right side beam column. That's the check on this area. column fracture yielding, column web yielding, column web buckling, column web crippling, column panel zone shear. All these limit state check are related to the MC is at the column top location or not. If yes, these limit state capacity will be reduced. All right, so we change back to general. Okay, so that's the MC at the column top or not. Okay, and also the last one, copy being from right to left or left to right, because we have both side MC, MC beside on both sides of column. We can define the right side and copy the exact setting to the left side or vice versa. Okay, so that's how this works. If we change to the MC only one side only, right side only, that will disappear. All right, so we change back, we disable the column top option here. Okay, we say no, that's in the middle of the floor, okay, middle of the column, so there's no reduction of these column web crippling, buckling, panel zone shear check. There's no reduction on that. So that's for general tab. It covers most of MC options. All right, so come to the next section. You can change the column section. Currently it's 1240 here. We change to 1245. Okay, so the couple session library, we have AISC 14.1 and 14.1 metric name, which is exact the same session database, but you know AISC table, there's one column called metric name. All right, so we in Canada we using normally use metric system 1230, wide flange 1230. In Canada we define as wide flange 310/45. So we also have a CISC steel handbook shape. That's the Canadian steel design manual handbook section. All right. So this program is made in Canada, in Calgary. So we have these options. Okay, so we keep this 14.1 Imperial Systems. Now current section is 1240. We want to change it to 1245. Here you go. All right. So that's the properties of this section 1245. We hit OK. All right, so that changed to 1245, and we can also change the steel grade. Normally, grade 50 is the way to go. You want to change it. We have ASTM or CSA Canadian steel grade, but you know there's no Canadian mill produce this Canadian steel grade. Everybody is using ASTM. Substitute 8992 or 8572. All right, so we have the option of custom input. You can key in your custom steel yield stress and ultimate stress here. It's provide you another options like sometimes you import the foreign steel from China, from Europe, okay, UK. Sometimes you are designing 30 years old plant. You want to use reduce yield stress. That's the option for you. Okay, we cancel it. All right, so that's section part. The Bing section change is the same way as the column. We change the column section size. We change the column section grade. Okay, now we go to the right end plate. Okay, we have MC on the right side only. Now you see the side view of this one. Well, better to explain to you using the front view. We change the front view here. All right, so in this tutorial, we are going to introduce the extend end plate only. All right. We'll talk about the other one, flange plate, in the next tutorial. So we have an option. Go to AISC Design Guide 4 or 16. We have the option of top extended and bottom extended. That's in the rooftop. We probably want to try top flush, bottom extended. All right. So the top flush, okay, I will talk about this. So top flush, bottom extended. Okay, so there we can also try bottom flush and top extend. Okay, so all controlled by this one, this pull down. So and both flush it. Okay, top and bottom all flush. Okay, we don't have extended plate, but we have some capacity here. You want to design this as MC. See here. All right, so it's a fail here, but we go back to top and bottom extended. All right, so we have this tooltip here. I keep popping up. We have tooltip here. It's on. Okay, tooltip here is on. So when you even with top and bottom extended, we call it for both. Okay, we have other options of both patterns. Okay. So when we move the mouse, let's call extended bolt pattern here. We move the mouse over, you will see a pull up. Okay, that because that one has this connection pattern naming. Okay, which is 4ES, 4E. 4E means 4 bolt extended. Okay, 4ES means 4 bolt extended plate with stiffener plate. It's this guy with stiffener plate. And 8 bolts, whatever. 4W is 4 bolts, 4 column. So these are all naming from AISC Design Guide 4 and 16. In case this pull up, okay, in case you don't have these two design guide handy on your hand, you can see the pull pattern you want through this pull up menu. All right. See here, pull up menu. There. None of the other program has this options for different type of bolt pattern for MC. Okay, well, most of them have these 4 bolt extended only, and we have more options because actually we provide more options than AISC Design Guide 4 and 16. They have some bolt pattern type not in these two design guide. But there are research work by the same, some research work paper by the same authors of these two design guide. We incorporate them, all right? So there are a big variety of options here for engineer to choose, okay? So that's the bolt patterns. Okay, so we turn the 2T off now. As long as you are familiar with that, okay, we turn the 2T off. We demo you through 4 bolt extended. Okay, probably with stiffener plate. See here, 4ES. Okay, with stiffener plate on top and bottom. Okay, that's stiffener plate. You go to side view. Okay. All right. So let's stiffener plate. Okay, turn it off, go back to 4 bolt extended, okay, without stiffener plate. So that's the option, and you can play with it yourself. Okay, we back to front view. Okay, these parameter defining the bolt spacing, gauge, pitch. Okay, so see the every time I move the mouse over the input field, check the left side sketch. The corresponding dimension get highlighted in yellow. All right, so gauge, okay, gauge is 4 bolt distance on the outside flange is this one, inside flange, edge distance, okay, plate thickness and plate width, sorry, plate thickness. All right. So again, to the bolt diameter and SC means 3 critical, yes and no. And bolt type, it's a thread include or thread exclude, A325 or A490. You can change them by click on edit button here. Okay, so edit button, we follow HTML code. We have both material grade, thread include, thread exclude. Okay, we have bolt diameter from pull down, 3 critical or not. Normally in MC they are not a big concern for 3 critical, but if you pick yes, all right, and you have surface class, the whole type or whatever, we change back to no. All right, so that's the bolt diameter. We keep 3/4. Okay, so these are all define the end plate bolt diameter, spacing, the dimension, all this plate thickness, plate width. Again, there are a couple of suggestion value here. Okay, and that's our best estimate based on our experience. If you want to copy all of them, you can hit this button. So now we talk about a weld. All right, so switch to weld. There are 2 weld. One is flange, being flange to end plate is this guy. We go here, and one is being web to end plate. We set up 2 because the thickness of flange and weld, and the critical or the weld on web normally is for shear resistance, and the weld on flange is for the couple created by moment. So there should be different input here. See here. Okay, and also you can, again, to define a grade, we have 70 KISS. Okay, 70 KSI. Okay, so that's for weld. And we go to stiffener double plate. That's better view on the side view. All right, so we switch to side view, and for now there's no current stiffener plate, there's no double plate. If you want to add stiffener plate, you can click on yes. Okay, then there will be stiffener plate. Okay, the thickness, the width, all right, the creep. Okay, the creep is better in top view. All right, the creep is this corner creep. All right, that's the creep. 75, 3/4 creep. All right, see the highlight. Okay, the stiffener plate can be full depth, can be half depth. All right. Okay, half depth. All right, that's half depth. And now, if we want to, besides the stiffener plate, we also want to add double plate. All right, the column Panasonic shear fail. We add double plate. Okay, so that's double plate. Again, they can be both sides. Okay, one side. We'll go to front view, top view. Okay, you want to patch double plate on one side only, or both sides. Okay, that's one side. Here we can 2 sides. You patch both sides. Very expensive. Okay, so double plate, the man hour, the labor cost is very high. Normally much higher than the material itself. Increase column size. In AISC, they call it clean column, without stiffener plate, without double plate, but they use heavy member. So here the double plate on both sides. Okay, one side, both sides, and double plate thickness, and stiffener double plate steel grade. Same thing, you can change it. All right, so we turn it to side view. Okay, side view. we turn it to no for both of them. Stiffener plate, double plate, we turn it to no. All right. Then we have only double plate. Okay. We stretch the double plate because when you have these force coming in, it would just spread out. So you have to patch longer to catch this spreading stress. All right. So we turn it off. No double plate. All right. So that's stiffener plate and double plate. Then we go to design load. All right. So when you go to design load, you better go to low view here. It will show you the load. Okay. So here you go. So that's the moment. Okay. That's the actual force. Negative value for tensile, positive for compression. That's the shear force. See the left highlight part, moment, actual, and shear force. Okay, the moment currently is counterclockwise. If we type in negative 45, it will be clockwise. See left, it will be clockwise. Okay, the moment changed to clockwise. The actual, okay, now is tensile. Being actual is tensile. We change to 25. You will switch. You will change your direction to compression. 25. Okay. Okay, it changed to compression. So that's the force, and we have also column storage shear and column actual load with these two guys. All right. See the highlight one. See the highlight one. So that's a design load. Finally, design calculation. All right. So we have this one. We have summary. We have beam to column. Okay. These are all limit state. And check. Okay. See the AISC design guide 16 is used because the end plate thickness is too thin. Currently, we have what's the plate thickness? It's 3/4. We change to 1 inch. All right. So now it gets thicker. So then, if it's thick enough, no prying, or still 16. Why is that? Still 16. And plate. Let's try 1.5 inch then. Let's try 1.5 inch. It probably is because of column. Let's see, because we have check on column flange as well. We use heavy column. 1.5 inch. Okay, so that's because of column. We click on this one. That one is because of column flange. End plate bearing. Thin plate. Okay, so that's column flange bending strength. So the column is too thick, all right. So we increase the thickness of end plate. Let's use this because when we check the prying, we check both end plate and we also check column flange. All right, the column flange is too thin. The thickness is 1/2 inch only. 575. We want to change it. Want to increase the column 575. Okay, increase the column flange thickness. We add it. We go to let's say 12 50. See you get thicker or not. 640. Okay, probably works. Okay, let's see, 1250. Okay, 640.640. Design calc. All right, so now design guide 4 is used. Now our column flange get thicker. Okay, it's thick plate now, so we change the end plate thickness back to 1/4 enough, or too thick. You see, 1.5 0.75 will work. Okay, then we go to calculation. See one more time. It's AISC design guide 4, right? So that one's thick plate now, no prying. All right, so you want to see whatever calculation, just click on it to get these expanded. All right, and also you can add a sketch here, and these MC sketches here now with side view, front view, top view, low view. We before we print it, okay, we expand all of them. Expand all of them. Here you go. So all the detail calculation is here. Now we print it. Hit print button. We pull up a new window. That's Chrome. Okay, right click anywhere and hit on, just like you print a web page, normal web page in your browser. We hit on print here. Okay, so now it's a loading and preview. See this one? Okay, all the calculation, and here that's date. That's date. Company name, project name, moment connection ID. Okay, so we hit print. Okay, my first calculation, my second calculation. Okay, my first MC calculation. Save it. All right, so it's printed into my PDF printer. All right, so just wait. Here you go. That's my PDF file. So we have this calculation print out. Okay, and summary sketch. PDF. Okay, so all the calculation step is here. All right, so you can just print out and you finish your first moment connection design. All right, so that concludes our today's tutorial on moment connection with the example on extended end plate moment connection. And we will continue with the moment connection flange plate moment connection in next tutorial. See you next time. Bye bye.